So, bond finance. Again, readings, there's no way that you should read all of them. Just pick your favorite. I highlighted the Lange Saunders Cornet book because if you want to read up about duration, these are the relevant pages here. They go again a little bit further than what we did do in class, but these pages is what we will cover in later chapters as well. So if you want to know more about duration, that's the way to go. I'll let you read this one first. Don't worry if you don't understand everything. That's perfectly normal. That's the reason why we've got that class, but I just want you to digest it first. So what do we have here? It's the Australian Financial Review, so a very reputable newspaper. You would think that's quite decent what they're publishing. There was some kind of new bond issued here. So a piece of paper like this, just instead of having 5 coupons for, let's say, 5 years, if you pretend this one is 5 years, it has 30 years running time. So you get the final value of your money back after 30 years in 2047. And it's got certain coupons attached to it, doesn't say exactly how much, and a certain yield, 3.27. And here, Katrin King, Director of Research and Strategy, so sounds like a quite clever person, right? She says, it's an extremely attractive yield. Yield is a different word for interest rate or return. And it's got a AAA rating. And the A rating is basically how likely is it that you get your money back. And AAA is top-notch. So it's very likely that the Australian government won't run away and say, I don't repay you. So it looks good. It's safe and it gives you a fairly decent return, 3.27. Much more than the bank is usually right now paying you. Right? But the question is that really a good investment? And we don't know with the information that is given here. But hopefully we're more able to assess it by the end of the lecture. So just keep that a little bit in the back of your head. We will come back to this one at the very end of the lecture. Good. First, starting with interest rates and bonds. I'm just going straight into it. Time value of money. So that's a basic concept. So the idea is when you prefer to get money. Let's say if I offer you $10, do you rather have $10 now or should I give it to you next year? Right. Most of you, I imagine. Who wants to get the $10 next year instead of now? Nobody, right? Because there's an advantage to get the money earlier. One of the simple advantages is if you get the money earlier, you can bring it to the bank and you can earn interest rates on it. For example, if the interest rate is, if you're pretending it is 10%, then these $10 until next year become $11. And $11 next year is better than my promise to give you $10 next year. Right? And we distinguish here between so-called future value. That's the value the money or any kind of finance is getting towards into the future, and the present value, how much we value something right now in the present spot. And the connection between them is that the future value is equal to the present value times the interest rate, or the interest rate factor, 1 plus I exponential n, that's the number of years here, that we can earn in it. So let's do this a little bit step by step. Let's say, for example, the interest rate is 10%. And by the way, in this class here, usually when we say 10%, we just write it in math often down as 0.1. It makes our life easier. So $100 in the bank, if you put that in the bank, we get $100 times 1 plus 10%, 0.1, means in the future we will have $110 on the bank account. Now, if we leave that money on the bank account, we can again earn 10% on top. So we multiply it again with 1.1 and we end up with 121 after 2 years. And so on, so on, so on, so on. So you can see here in the math, basically you can just make it exponential. So you have the interest factor here and write as an exponential the number of years. Because for 1 year it's times 1.1. For 2 years it's the first 1.1 times 1.1 again. Third year, 1.1 times 1.1 times 1.1, and so on. If you didn't have that beforehand and you struggle with it, you need to start practicing this stuff. So this is very basic, and we all need to be on board with these things. Good. For the present value, you can just flip it around. Basically what we do is we take that formula from here and say, now, how much money do I have to put in the bank if I want to get $110 after 1 year, if the bank is offering me 10% interest? And the answer is simply 110 divided by that bracket. Let's make the question a little bit trickier. Let's say if I want to get $121 in 2 years' time, and the bank is offering me 10%. How much money do I need to put on the bank account right now so it grows to 121 within 2 years? $100 exactly, right? We can see that here. If you put $100 onto the bank account for 2 years, after 1 year it's growing to 110. After the second year, we will have 121. And in economics, and in this class, we call this one simply the present value. So whatever money we get in the future, we want to be able to calculate present values. Because otherwise we can't compare, right? What is better, $105 next year or $100 now? Well, it depends upon the interest rate. Speaking of the interest rate, we sometimes call this one here also discount rate or discount factor. Timeline. It's quite useful to have timelines in your head. So what does that mean? We have here simply the time that it takes until we get the money. So no time at all means we get the money straight away. 1 means we get the money after 1 year. 2 means we get the money after 2 years. And n means after n years, and so on. So if we want to calculate the present value of a stream of payments where we get, let's say, $100 each year for n amount of years, the idea is, well, we have to add up all the present values. So the first one is the easy one. If you get $100 straight away, what's the present value of that one? 100, right? So that's easy because we have to not discount it at all. This one is a bit harder. If you get $100 in 1 year's time, we need to discount it for 1 period. And depending on how much the interest rate is, we get a smaller or bigger number, but for sure smaller than 100. For 2 years, we simply add exponential 2 here, and 3 years exponential 3, and so on for n years. And we add all these up. And you can see here, there would be a lot of calculus and would be a bit painful. And I don't expect you to make huge calculations with lots of numbers. And therefore I prepared a spreadsheet for you. So you can open up the Excel spreadsheet. So this is the spreadsheet here that is behind bond finance. And it's very useful, in my opinion, to practice it a little bit, to get a bit of a feeling what's happening with present values and with bond prices. So the first task now is to use this spreadsheet here. Don't get shocked by the formulas. And plug in the numbers at the right spot. So basically you can put in the numbers at the yellow area. So these are the cash flows at different times. Cash flow in year 1, cash flow in year 2, year 3, and so on. For year 10, I've got 2 cash flows here, because usually what you get in the last year is the last coupon and the face value in your back. Good. I'll let you have a go at it. So one was $100 each year and 1,000 in the end. So that's worth like $1,000. So that's the present value. By the way, these are the present value of the initial payments. So these are discounted for 1 year, discounted for 2 years, discounted for 3 years, and so on. So you can see the further in the future the money goes, the less it is valuable right now. If you have to wait 9 years for $100, you would evaluate that as the equivalent of $38.55. So if you have a choice to get either $100 in 9 years or $38.55 right now, if the interest rate is 10%, they would be the same for you. $100 in 9 years, $38.55 now is the same if the interest rate is 10%. And if you add them all up, you see that the present value of the whole piece of paper, these cash flows, is 1,000. And here it was Okay, so which asset is better? They're pretty much both the same. So maybe if you're risk averse and really don't want to wait to get your first payment, you might say, I personally like A better, but from a present value point of view, they're both the same. They both have the same value. So your turn. Calculate the present value of $1,000 that you will receive in 5 years. So there's no other cash flow, just $1,000 in 5 years. And now the interest rate is 6%, so we changed the interest rate. There's two ways to do it. Either you can use, again, the Excel sheet, or you can try to make up a formula to calculate that one, where you basically discount something at 6% for 5 years. So just the timeline that you can see what's meant here. Basically, after the dollar value that we have to put in the bank now, so that if you get 6%, 6%, 6%, 6%, 6%, we end up with $1,000. The future value is $1,000. So we want to know $1,000 in the future, how much is it worth now? How much do I have to put in the bank now to end up with 1,000? So basically, after the present value, if you would multiply the present value by 1.06 exponential 5, we end up with 1,000. So we can flip that around and divide it by 1.06 exponential 5. So we get this one. And that one, of course, I can't do in my head either. And I make a little sheet and go back to the Excel sheets. So let's see what we've got. We don't get any payments in between, but in year 5, we get 1,000. So it's 747.26. So if you put 747.26 cents into the bank now, get 6% each year, don't touch it, we will end up with $1,000. So $1,000 in the future, in 5 years' time, is the same as 747 now. If I put in a higher interest rate, discount rate, the value here will go down, which makes sense. Because if I get 10% each year here, I don't need to put as much money into the bank now to end up with $1,000. But that also means that $1,000 in the future is worth less now if you're using a high interest rate. And that's going to be very, very important if you talk about the evaluation of these bonds. So now we talk about different credit market instruments. Simple loan, there's something like fixed payment loans, but for this class I don't want to go into too much details in these. I want to talk mainly about coupon bonds and discount bonds.